Hi everyone, just wanted to take a minute to talk a little bit about the volumes of cylinders and prisms. So we're kind of moving beyond surface area into dealing with volume. So just to clarify and make sure we're on the same page, volume, it is kind of the amount of three-dimensional space that an object will occupy. So before, when we were just dealing with area, right, we were kind of looking at how much space on like on a plane. Um, Whereas with volume, now we're getting into the third dimension and we're trying to figure out how much things uh, or how much space will be taken up. So, you could be dealing with like filling things with like gases or liquids and things like that. Don't forget when you're dealing with volume, because you're going to be essentially multiplying, length, width, and height, you have to have your units cubed. All right. So centimeters cubed, cubic meters, whatever the case may be, you have to remember that your unit has to be cubed, and that is something that we're going to be on the lookout for. But don't forget the cube component. All right. Okay, so we're going to start off back with our prisms. So as you would probably guess, uh, it is going to come down to the base of your prism. As you recall, prisms are going to have the two bases that are the same. They could be triangles, rectangles, hexagons, pentagons, whatever. Um, and then if you kind of like think about it, if you were to take it, put the base on the bottom, and then stack it, you're taking that how much area the base is taking up and just kind of stacking it however high the height is. So that's why the formula is the area of the base just times the height. And don't forget, if you have something that looks kind of, like this, the height might be outside, so don't be careful with that if it is oblique. But we are dealing with the height. All right. So, for example, we need to find the area. I'm sorry. Yes, in order to find the volume, we have to find the area of the the triangle. All right. Now, you have an equilateral triangle where this is 5, this is 5, this is 5. But right, in order for us to be able to solve this, you have to know the height of the triangle. So if we put in the height, oh, that cuts it in half, which makes this a 30, 60, 90, because they don't go away. So you have a right triangle, right? There's your, oh, I'm sorry, that's the 60. There's your 60. This is 2.5, or 5 halves. And here's 30. Okay, so that would mean the height would be, and I'm going to do 5 halves. So 5 root 3 over 2 using what we know about special right triangles. Okay, so now we have to find the area of the triangle. So the area is equal to 1/2 base times height. Now the base is 5. The height is 5 root 3 over 2. Now, if you kind of ask yourself, well, what even is that in terms of a number? And we are just going to leave it as is. But we know that the square root of 3 is close to 2. And then when you divide by 2, so that kind of gives you a height of like 4.3 or so. But this is close to 2. So when this divides, it's going to be a little bit smaller than 5. Anyway, so when you do that out, you would get 25 root 3 over 4 inches squared. And if you ever have to see me look over, I'm just looking at my calculator just to make sure I don't accidentally make a mistake. Okay. And we can just leave it like that. And you'll notice I've only done the area so far. So right now my unit is inches squared. Now, to find the volume, you take that number and you're multiplying it by 9. So 25 root 3 over 4 times 9. Now, again, if depending on how it's oriented, you might end up having to have, the height in this case where it's kind of flat. Sometimes it'll be vertical. You just have to pay attention to how it's kind of oriented. So times 9. So let's see. Well, that would be 225 root 3 over 4, because you can just multiply the 25 times the 9. And I'm just going to leave it as is. Why? You don't have to worry about plugging it in. Again, you know it's going to be times 2-ish divided by 4, so it's going to be roughly a little less than half of 225. But ultimately, you can just leave it as is. And don't forget it is inches cubed. So that is ultimately how you find the volume. Be careful, because you will potentially have to use either trig or special right triangles. Now, continuing on with a cylinder, as you would expect, it's just going to be, the area times the height. And once again, if your height is, if it's oblique, your height won't be outside. So let's find it. We need, first of all, we can find the area of the circle easily. It is radius squared times pi. Now, the radius is not 7, the diameter is 7. So it's 3.5, or 7 over 2. Now, this is a perfect example of why it is easier to leave it in a fraction, because I know what 7 over 2 squared is, because I know that 7 squared is 49, and I know that 2 squared is 4. If I did 3.5 squared, I don't know what that is. Not off the top of my head. I mean, you can do it, but this is something you can easily do. Times pi. Now I'm going to leave it as is. Feet squared. Okay, so again, I'm leaving this as is. There's no point in you turning it into a decimal when you're going to have to then multiply it again later. Sometimes, if you have the fraction, you'll notice things cancel out nicely. Now we need to multiply by the height, which we don't have. So we have, well, we essentially have a right triangle here. So to find the height, we need to use the Pythagorean Theorem. So 49, I'm going to call it h squared, equals, what's 25 squared? 25 times 25 is 625. So when we subtract 49, you get the height squared is 576. Now, if off the top of your head you do know what that is, you'll know that this is actually just a Pythagorean triple, because that's just 24. So this is a Pythagorean triple. That, I'm not going to lie, 576 off the top of my head, I didn't fully remember it. I looked at it and was like, I think I know that number. But if you do happen to catch that it is just 24, you might have known that this was a Pythagorean triple. But anyway, we have a height of 24 feet. So now we're going to multiply. See, now this is a perfect example of what I was talking about, because if I had left this as a decimal, there's not anything inherently that looks like it would cancel. Maybe not off the top of my head, but when I not 25, I'm sorry, 24. Okay, now the 4 and the 24 are going to simplify. So you're going to have 49 pi times 6, because 24 divided by 4 is just 6. So now it is an easier operation to handle. I can figure out what 49 times 6 is, right? Well, let's think about it. What would 50 times 6 would be 30. 300. And we're subtracting 6, so it should be 294. Yeah. And again, all I'm doing with that is I'm saying, well, what's 50 times 6? It's 300. Because 5 times 6 is 30, add the 0. And it's not 50, it's 49, so you subtract the 1, but you're doing it 6 times. So there it is. All right, and I'm going to leave it as is. Oops, not squared, cubed. All right, so that is how you find the volume of a cylinder. Let me know if you have any questions, and have a great day.